In our lesson today, we're going to be analyzing percents of numbers. And in our first example, we're going to be looking at the charge of a cell phone battery. We're told that Diego starts a 12-hour road trip with his phone's battery charge at 75%. Given his normal usage, will his phone last the whole trip? And remember that the whole trip is going to be 12 hours long. Okay, so what we need to do is look at the picture, and we can see in the top part here that a full battery, a 100% charged battery, would last 15 hours. If you look underneath, well, this represents Diego's, where it's 75% full, and we don't know how many hours that's going to be. Okay, we could represent this with a tape diagram as well. You might remember tape diagrams from 6th grade. At the beginning, in terms of percents, is 0%. And at the end is the whole tape diagram, which is 100%. And they've told us that that would be 15 hours total. Okay, so 0% would be 0 hours, 100% would be 15 hours. We're told that his battery charge is at 75%, which would be right about here. 75%. We don't know how many hours that's going to be. Okay, so we could see that the whole battery, 15 hours, we're looking for the part, 75%, that his battery will last. So we're going to start by writing the percent equation. And if you remember from the last lesson, the percent equation says part equals percent times whole. Okay, and we're always looking for a percentage of the whole. All right, so we know that he's at a 75% charge. When we use the percent equation, we need to change the percentage into a decimal. 75% as a decimal, well, you have to move the decimal point back twice to the left. So that's going to give us a decimal of 75 hundredths. So I'm going to replace my percentage there with 75 hundredths. And again, we don't know the part that that's going to represent, but we do know that the whole battery would be for 15 hours. So I'm going to put 15 in the whole spot, and P, the part, is what we're looking for. So P is already by itself on the left-hand side. To get its value, you're going to have to multiply on the right-hand side 75 hundredths times 15. If you punch that into your calculator, you're going to get 11 and 25 hundredths. This means, if we go back down to our tape diagram here, okay, this question mark here now, we know is 11 and 25 hundredths hours. That's how long his phone is going to last. So remember, his trip is 12 hours long. Will his phone last the entire time? Well, not if it's only going to last 11 and 25 hundredths hours, okay? So we can say the phone charge will not last for the entire 12-hour trip. Again, P was equal to 11/25 hundredths hours. So he's going to run out at some point, so Diego's going to have to find a phone charger so that his battery doesn't die. In the triad example, we're told that Katie's phone had a fully charged battery. With normal usage, her phone will last 18 hours. How much time is left on Katie's phone battery at a 12% charge remaining? So again, we can think of that tape diagram that we drew in the last example, where we have 0% at the beginning of the bar, 100% at the end of the bar, and they tell us that when her phone is fully charged, it will last for 18 hours. So a 100% charge is 18 hours. 0% is obviously 0 hours. They want to know how much time will be left when her phone battery is only at 12%. So right about here, we can say that that's about 12%. And again, we don't know how much that is going to be, but we can use our good old percent equation. Part equals percent times the whole. So again, we're looking for how much time will be left at a 12% charge. Remember, you have to change 12% into a decimal. Move that decimal point back 2 times to the left. That's going to be 12 hundredths. So that's what we're going to put in the percent spot. 12 hundredths. And we don't know what part 12% represents. That's what we're looking for. So P is the part. But we do know that the whole battery, 100% full, will last for 18 hours. So P is already by itself on the left. To get its value on the right, we're going to have to multiply 12 hundredths by 18. If you go and punch that into your calculator, 12 hundredths times 18, we get 2 16 hundredths. Okay, so this means that at 12%, Katie's battery has 2 16 hundredths hours left. Okay, the whole battery will last for 18 hours, but at a 12% charge, that's going to be 2 16 hundredths hours. In our next example, we're going to be using a percentage that is greater than 100%. They tell us that a full set of adult teeth includes 160% as many teeth as a full set of baby teeth. How many teeth are there in a full set of adult teeth? Okay, when your percentage is over 100%, that means the amount is going to be more. Adults have more teeth than babies do. So to figure out how many teeth there are in a full set of adult teeth, we know our answer has to be bigger than the 20 baby teeth that we start with. Okay, so to get the adult teeth is 120% of the baby teeth. Okay, we have to do, 160% of the baby teeth. All right, we have to take the amount of baby teeth we have and increase that by 160% in order to get the number of adult teeth. So we're going to start by writing part equals a percentage of the whole. And we have pretty much already set up the problem when we did it right here up above. The adult teeth is going to represent the part that we are looking for. That's the unknown that we need to figure out. 160% is going to go right in here, but remember, we have to change 160% into a decimal. 160% equals, remember, move the decimal point back 2 times to the left, once, twice, so that's going to be 1 6/10 that we put in the percent spot. And the whole is the amount of baby teeth, all right? We're finding 160% of the baby teeth, so that's going to represent the whole value, and we start with a whole value of 20 teeth when we are babies. So in order to get the number of adult teeth, which is our part P, we're going to have to multiply 1 6/10 by 20. If you were to punch that into your calculator, you would get an answer of 32. And this answer makes sense because, again, adults have more teeth than babies do, so our answer should have been bigger than 20, and it is. So we will say a full set of adult teeth contains 32 teeth. Okay, so again, if your percentage is bigger than 100%, your number is going to get bigger than the whole value that you start with. In the next example, we're going to look at a percentage that is less than 1%. It says, what is the approximate distance in miles from the Earth to the moon? And what they've done is given us a diagram, okay? So here's the Earth right here, and here's the moon. And this little distance here is what we're looking for. And they've told us that this little distance is 27/100% of the distance between the Earth and the sun. And if we look over here, this is the sun, and they've labeled the distance between the Earth and the sun as 93 million miles. The Earth and the sun are 93 million miles apart. We have to figure out what this little bitty distance is between the Earth and the moon. Okay, so once again, we're going to start by using the percent equation. Part equals percent times whole. Okay, and remember for our percentage right here, all right, it's 27/100%. This is the percentage that we have to change into a decimal. Well, 27/100%, remember, we have to move that decimal point once, twice to the left. So that's going to turn into 27/10,000ths when you change it into a decimal. And that's the number that we're going to record in the percent spot, 27/10,000ths. Now, we always find a percentage of the whole. The whole in this case is going to be the distance between the sun and the Earth, which they've told us right here is 93 million miles. Okay, so since we find a percent of the whole has to be 93 million miles. We're looking for the part of that that represents this distance right here between the sun, the Earth and the moon. So P, the part, is already by itself on the left. To get its answer, we have to multiply 27/10,000ths by 93 million. All right, so use your calculator, punch these numbers in carefully. There's a lot of zeros here. If you do that, you should come up with a value of 251,100. Okay, so that represents this distance between the Earth and the moon, and that is measured in miles. So we can say that the distance between the Earth and the moon is about 251,100 miles. In our last set of problems, we're finding a percentage of a number. In letter A, find 0.08% of 720. In letter B, find 162.5% of 200. And in letter C, find 0.3% of 60. Remember, for our percent equation, it's written as part equals percent times the whole. You're always finding a percentage of the whole. And so that's what we're looking for in each of these problems, a percentage of the whole. The word of is always attached to the whole value, all right? What we're finding is going to be the part in this case. So the part is going to be equal to 0.08%. We have to change this percent into a decimal. I'll do that down here. 0.08% equals, remember to move the decimal point back once, twice, fill in that spot with a 0. That's going to come out to be 8/10,000ths. So that's what we're going to put right here in the percent spot, times the whole value, percent of 720. 720 represents the whole value. So now when we punch this into our calculator, 8/10,000ths times 720 gives us an answer of 576 thousandths. Okay, so 576 thousandths is 0.08% of 720. In part B, we're finding 162.5% of 200. So once again, we'll start with the percent equation. Part equals a percent times the whole value. And we always find a percent of the whole. So the whole in this case is going to be 200. We know our percentage. What we're finding is the part. So P equals 162.5%. Change that into a decimal first. 162.5% equals, move the decimal point back once, twice. That's going to be 1 and 625 thousandths. 1 and 625 thousandths times the whole value of 200. So we're going to punch this into our calculator, 1 and 625 thousandths times 200, and that gives us a value of 325. And this answer makes sense because, once again, our percentage right here was over 100%. Just like we looked at with this example with the teeth, when your percentage is greater than 100%, your end result has to be bigger than what we started with. Our end result was 32 teeth. We started with 20. Well, in this example, our end result is 325, and we started with 200, and that makes sense because this percentage was over 100%. In our last example, we're going to find 0.3% of 60. So the percent equation, again, is part equals a percent times the whole value. And we always find a percent of the whole. So 60 is going to represent the whole. We have our percentage. We're finding P, the part, equals. Let's change 0.3% into a decimal. Move that decimal point back once, twice. So we're going to have another 0 there. That's going to be 3 thousandths. So let's record that there. Times the whole value of 60. And when we punch this into our calculator, 3 thousandths times 60 gives us an answer of 18 hundredths. So 18 hundredths is 0.3% of 60.